Hello everyone, I welcome you all to this 30 days masterclass series on electric vehicle design using MATLAB Simulink. And today is day 29 and our topic is EV model fabrication design. So in this class we are going to discuss about what are the procedure to start our hardware, and before starting the hardware we should understand how the entire hardware is going to implement. So the planning we are going to work in detail. So keep engaged with the entire class. I welcome you everyone here. I welcome Nanda, Hitesh, Sanchit, Neelesh, and Madhavi, Satyanarayana, Suswant, Rambabu, Ashif, Bhuvan, Siddesh. Warm welcome, participants. First of all, I would like to say sorry. I'm extremely sorry for this late class scheduling. So, due to the internal technical issues, I couldn't able to arrange on time. So, please bear this delay. Yeah, am I audible now? Am I audible now for everyone here? Can you please comment? Am I audible now? Can you please comment? Am I audible now? Yes. Thank you. Yes. So let's start the class. I think my image is not. Yes. So about the Pantech, Pantech is an educational equipments manufacturing company, and our vision is to help 10 million students to learn the technology in easy way. So far, we have trained about 1.5 lakh students, and attendance. Sorry, actually, batch 5 is going to start. Batch 5 is going on, and till 21 you can join in the batch 1. So this is the last batch. Yes, this is the last batch. So batch code is batch 5. Yes. So attendance form will be provided at 8:30 p.m. So please submit your attendance form. And actually, let us start the class. So are you ready to learn the concept? Are you ready to learn the concept? If you are ready, please. If you are ready, please comment in the comment box. Yes, Mr. Sanjeev, solar system webinar 30 days masterclass is going to start hopefully by October first week. Yes, thank you, participants. So now, first we are going to understand the hardware principle. So how you can start your electric vehicle? Where, at which point you should start the electric vehicle? Because actually the electric vehicle is not a rocket science. So those who are all participated this 30 days class, so definitely they can develop their own electric vehicle. Okay, so on this manner only I have created the content so that you can source the component wherever you are from the locally. You can choose alternate options also. Suppose if you are decided one component, if it is not available, so in that case you can choose alternate options to finish the project, right? So in that aspect only I have created the content. So first we will discuss about the hardware design, how the things will be there, and then what are all the procedures are there, steps of steps to complete the project, and the structures of the vehicle. Actually, basically, if you take any vehicle, the first point is that structure. So how you are going to design your structure? Since it's being a prototype of EV system, so you don't worry about the structure. Suppose if you are going to design the proper structure, then there you should analyze finite element analysis and structure analysis, stress analysis, everything you should do. But since it's being a prototype model, so here we can keep one constant rectangle square bar, so that will give you the complete solutions. So you don't need to worry about that structure. And similarly, components of the EV is very simple, right? So it's not like a IC engine vehicle. So it's a EV vehicle. So the entire mechanism is so simple. So I will tell you one by one. So keep engaged with the entire class. And next one, the type of drives. So the type of drives nothing but either are you going to drive your vehicle with a single motor or dual motor or four-wheeler motor. Sorry, four all-wheel drive motor. So anything you can choose. So it's up to you only. Then selections of the specifications for the EV. So what are the components you should choose? So what are the components you should choose? So this topic we will discuss in detail. So keep engaged with the entire class. So hardware design. So first we should confirm the specifications of the vehicle, and the second one is the vehicle structure and motor selection, and finally you have to go for the controller design. So here the controller design comes up with two controller design. One is called Powertronic controller, and another one is called Arduino controller, that is microcontroller. So you can choose any one controller. So based on the Powertronic specifications, you can choose the microcontroller. So which microcontroller do you want to keep, then you can use it, right? So now let us check the specifications. First one is specifications. I took 140 kilogram weight. So actually, since it's a prototype, so I have I choose very as much as less weight vehicle, right? So the entire weight of the vehicle will be about 20 to 25 kg. And after that, a rider vehicle, rider weight I have added. So totally 140 kg is the total entire weight. And length and then width, the 0.9 and then 0.5 meter. And rolling resistance 0.0, because actually here I am going to use the as usual tire. And it's made up, the vehicle is considered, we are going to drive a vehicle on the tar road only. So in that case, the rolling resistance also we can keep considerable rate. And similarly, the drag coefficient we can keep huge, because actually it's not a aerodynamic design. So again, that is entirely different concepts, the aerodynamic design center, right? And similarly, the speed of the vehicle I took about for 20 km per hour. So 20, or sometimes we can have a 25 km per hour. So 25 km per hour, right? So if you calculate these things, then you can get a final frontal area as well as the velocity of the vehicle, and rolling resistance and then total power. So you need about 438.981 watts. Suppose if your motor has this much amount of power, then you can successfully drive your vehicle, right? So this is the idea. Before you start the vehicle design, then you should have these informations. Is it clear? Do you have any questions? Today is not last day. Tomorrow only the last day. Is it clear? Do you have any questions about this one? Do you have any questions about this one? Super legend. So now, next step is the vehicle structure. So the vehicle structure, see here for the traditional vehicles, so they will concentrate more on this vehicle structure. So with the different type of material combinations they will use. But So these are the traditional vehicles like made up of carbon fiber and then aluminum and then steel. So different type of thing they have to do. So for designing the structures, they will use some solid oaks, solid oaks and then ANSYS. So this kind of softwares are widely used to finalize this design. Whereas in our hardware, in our prototype, so I took a four-wheel drive. See here, this is the side view of the vehicle. So this kind of this kind of vehicle only we are going to fabricate in our laboratory. See here the vehicle tire based on the cost effect I chosen. So this is a 12-inch dia of the tire, and then this is similarly this is a 10-inch dia of the tire for this tire, and this is the steering system. So this steering system is connected with the differential drive. So that is a universal connector is used to get this one, and in the back side of the wheel I'm going to keep my motor. So this motor will here I'm going to plan here I'm going to keep two motors. So that is a dual drive motor. I will tell you what is dual drive motor in the next slide. So keep engaged in the entire class. So this is my ultimate final output of the of my hardware fabrication prototype. Right. So this is the top view. See here, this is one wheel and this is the another wheel. Here I am going to use the motor 1 and similarly motor 2. And this is simple wheeling systems. So here just steering mechanism only is going to change the directions of the position of the front wheel. So based on this, we can drive the system on perfect manner. Right. So this is our final prototype structure. And so next step, motor selection. So for this for activating this motor vehicle, so now we have to choose the motor. So how we can choose the motor? First you should know what is the motor. So the motor is nothing but it's a device to convert electrical energy into mechanical energy. For that thing, so how you can choose the motor? So the motor should have a high efficiency, it should have high instant power, and then fast torque responses, to like that. So these topics we have discussed. But anyhow, if you keep all the specifications, the cost only going to finalize your project. So how much amount of money you are going to invest on your project, right? So I took a decision to reduce the cost so that the course users can duplicate this project at their own cost, right? Suppose if I keep different components, if they are not able to source the component on locally, then the entire our objective will become a failure. So in that point of view, I took all the components on very low cost manner. So if you grab the entire idea, then you can build your own vehicle, right? And so the here generally when you choose the motor, so you just keep in your mind the motor performance. For a different type of motor, you should be able to answer why you have chosen this motor and what kind of issue may arise while you keep the motor in your vehicle, right? So I generally in the motor performance region there are two regions. One is called the constant torque region and then constant power region. For each and every motor will have their own responses, right? For DC motor, so this is the operating range. So you can get a very slow operating range, right? Similarly for the induction motor, so this is the operating range. So in that case, you can operate the motor from 0 to maximum. At the same time, we can get a maximum torque, right? And for BLDC motor also little bit higher than the PM induction motor, and PMSM and then SRM will give you a ideal performance, right? So now you should choose based on this performance graph. You have to choose the motor. Suppose if you have chosen the motor at low cost, then you should be able to answer the questions why you have chosen the motor, right? So I am going to design my vehicle at very low speed, like a 20 km per hour, and I mean, I'm expecting like a constant speed. I won't drive much wide range. So I took motor. This motor. This graph. I'm going to take it because my aim is to reduce the project cost. So here there are different type of motors. Already we have discussed the same concept. Motor type, basically we have to classify under that commutator motor and then commutator-less motor. Under the commutator motor, there are two different types. One is called the self-excited and then separately excited. Right. So here self-excited, separately excited, there are different type of motors are there, like series motor, shunt motor, compound motors, and field excited, permanent magnet excited. So everything is there. And similarly, under the commutator-less motor, so there are different type of motor: synchronous motor, asynchronous motor. So asynchronous motor nothing but induction motor, and then synchronous motor nothing but like a permanent magnet synchronous motor, and then synchronous reluctance motor, switch reluctance motor. So many types are there. So you have to choose based on the requirement. Of course, in the market you can get all the motors, but you should choose why. You should be able to answer why you have chosen the motor. And for EV vehicles, we can use a DC motor, induction motor, BLDC motor, PMSM motor, and then SRM motor. So since I took a vehicle is a very low power, like 140 kilogram, so that is my ultimate weight of the vehicle. So in that case, I am going to choose the DC motor. So PMDC motor. So for a general thumb rule is for two-wheeler and three-wheeler, you can straight away you can choose a DC motor, PMDC motor or BLDC motor, right? For four-wheeler applications with traditional vehicles, then you have to choose DC induction motor, PMSM motor, and then SRM motor. So any one of these three motors is going to be a four-wheeler. So due to the weight consideration, I took a DC motor. Where I changed the PWM in the Arduino, so that reflects the implement the BLDC motor control. So that is too complex in your end, right? So in that aspect, I have chosen this DC motor to explore the complete idea. So if you repeat the same idea for all the motors, any kind of vehicles, right? So you have any questions? Why I have chosen the motor? Do you have any questions? Why I have chosen the motor? Yes, thank you. So now I have chosen this DC PMDC motor rating at 360 wattage. I am going to use the two motors. Right, my requirement is 460 is the 460 watt is the total power requirement. So I am going to use 360 wattage into 2. So in that case, about 720 wattage will be there. So in that, yes, I have. Why did you choose a DC motor only? So that's why I am trying to give you the answers. Right. So for worst case scenario, I have to use high power. Double the power requirement. So in that case, 720 will be the total power availability. 720, right? But my requirement is only 460. So 460. So here I can take from 0 to 720. I can take wherever it is. So with this one, I can adjust the hill climbing also. Right, so I can adjust the hill climbing also. So right, and then RPM is 250 RPM, and the motor length is about 330 meter, 330 millimeter, and rated voltage is 24 voltage. Right, so the rated voltage is 24 voltage. So now you have a questions about how to choose the battery. So can you just calculate how to choose the battery? How to choose the battery? So I took motor is PMDC. So I took a PMDC motor, and for actually I have chosen the two this motor for two reasons. One is called cost and controlling mechanisms. Right. So the low cost and then controlling mechanisms. So the controlling mechanism nothing but my intention is to give you the complete idea like a schematics, source codes, everything, right? So that you should able to reproduce the hardware. So in that aspect I have chosen this motor, right? So now you can ask your questions. So what is the battery capacity? So how to choose the battery? Yes, Mr. Praveen. Based on the range and then cost, so now you can choose the battery size. So the voltage rating, the terminal voltage is 24 voltage. So let us assume that battery, my vehicle should run about 40 kilometer, 40 kilometers. So this is the distance range. So for the 40 kilometer, then it will take a 2 hours time period, right? 2 hours time period, because actually my vehicle specification is maximum speed is about at the full load like a 20 kilometer per hour. So 20 kilometer per hour. So in that case, if you want to cover the distance of 40 kilometer, then obviously you should run the vehicle for 2 hours. So from this point you can identify the battery power rating. So how much voltage you should how much battery power you should keep in this phone. So now the terminal voltage will be 24 voltage. So the terminal voltage will be the 24 voltage. And here you have an option. So you can choose, you can go for the lithium ion battery. Suppose if you feel the cost is too high, then you can go with the lead acid battery also. So the solution will support, not an issue at all. Any questions? Any questions? The best is nothing but a BLDC motor is best. For the two-wheeler, BLDC motor is best. Any more questions? But the weight of the lead acid also is more, but it's negligible consideration. So it's a negligible consideration. Mr. Yogesh, I gave you the assignment for you. Calculate the battery size. So just calculate the battery power. How much amount of current is required? In case if it is a lithium ion, then you have to calculate the number of cells. So now you have two questions. One is how to choose the battery rating, and the second thing, if you choose the lithium ion battery, then how many cells you should buy. So just calculate the battery size and the comment in the comment box. So I am waiting for your reply. I'm waiting for a reply. Sir, my induction motor rating is 3 kilowatt, 48 volt, 1100 rpm. Is it suitable for EV bike applications? Yeah, you can use it. So accordingly, as per the motor rating, you have to choose the converters. So that's it. Can you repeat the motor specification just to recheck, rewatch the video? So I'm expecting reply from your participants. What is the battery size? And if you choose the battery as a lithium ion, then how many cells you have to choose? Lithium ion battery is 2000 milliamp or 3000 milliamp. It's up to you. You can choose whatever you want. So you can choose whatever you want. 24 voltage, 30 ampere. I have not calculated, so please participants, please come calculate the current rating and then confirm. How I could convert this training into internship? So just check, just take a internship registration link in this video description box, and then just enroll it. Then you can be into the internship. What is switch? Switch is that solid state relay. That is MOSFETs or IGBT. There is no any extra class. There is no any extra class. So tomorrow is the last class in YouTube. Yes, lithium ion battery for 27, lithium ion battery for 24 volt. Okay. Okay, see here you have a two question. One is called how to just calculate the battery size for these specifications, and second one, in case if you choose the lithium ion battery, the how many numbers of how many lithium ion cells needs to be connected in series as well as that parallel, right? Just to calculate it and then come back with the results for tomorrow class. Yes. So now we are going to discuss about the type of drive. So the type of drive is, this is called the single drive system. So single motor can drive the vehicle. So the common power transfer is connected for the two wheelers, two wheel, like a wheel one and then wheel two. So this motor will drive this vehicle entire system. Similarly for the dual drive system, see here this is a motor 1 and this is the motor 2. So this motor will take care of this vehicle and then this motor will take care of this wheel. So in the case the back wheel drive will power the vehicle. And similarly all wheel drive systems. The all wheel drive system nothing but all the motor will have all the wheel will have a motors, right? So all the wheel will have a motors. And see here while you keep this kind of drive system, you can get a better stability, better controllability, and you can reach the speed at maximum level, and then you can handle the load at extreme levels, right? So obviously this is completely suitable for the sports vehicles. Yes. If you have any questions, you can ask me. And the next one, next step, that is the final step. This is called the controller design. So now we are going to design the controller. So here for the controller design, so this is our requirement. Motor type is PMDC motor. Operation is 4 quadrant operations, and then motor speed is the 0 to 1000 RPM. So it's not the maximum, and this is motor speed. Okay. So the 0 to 1100 is the motor speed. Actually, by motor rating, see the motor can rate up to 250 RPM, but we are going to take care. We are going to take only that 100 RPM. So that is half of the speed only we are going to consider it. So this is called the worst case scenario. And the vehicle speed, you have a two range. One is called the 0 to 20 kilometer as well as the 25 kilometer per hour. Regenerative braking system we are going to implement. Regenerative braking system we are going to implement. And then controller for this specification. For this specification, you can use the Arduino Mega or Arduino Uno controller is enough. Suppose instead you can, if you are choosing that BLDC are suitable. So in that case, you should choose different controller. Right? So in that case, you have to choose the different controller. Could you provide any discount coupon for internship? Use batch 5 to get your internship discount code. Just use batch 5 EV. So you can get a discount. How you will use the regenerative braking mechanisms, and then how it is done. For the regenerative braking mechanism, the brake in the DC motor class we have discussed how we can achieve the how we apply the brake for the motor while if it is in the running conditions. That is called the regenerative braking mechanism. Just please check the class, DC motor control class. Please check the DC motor drive or four-wheel drive or single drive. For four-wheeler applications. For three-wheeler, you can choose it. Yes. Any more questions? Any more questions? Now, see here in our system we are going to use two 4 quadrant chopper. So this is a single quadrant. This is single 4 quadrant chopper for a single motor. Because actually we are going to use a dual drive system. For dual drive system, we have to implement 4 MOSFETs in 2 cases. Right. So now let us understand the concept. So let us assume that this is the motor. If you connect the switch 1 and then switch 4, the motor will be running under that forward conditions. Right. So let us take that anti-clockwise directions. In that case, if you change the pulse width or the PWM, if you change the pulse width, then we can control the speed. First one is the direction, second one is the speed. Right. So now how we can achieve the regenerative braking? So the regenerative braking in the sense, while if it is running in that say one directions, in that case you have to remove the gate pulse from this switch and then you have to enable the switch. So in that case, the back EMF available on the motor will be dissipated within this loop itself. Within this loop itself, this is called the regenerative braking. So that voltage you can take out, you can take it from the motor to the outside circuit also. So for that one again you have to put one rectifier circuit to store the voltage in the capacitor or super capacitor. Via the super capacitor you can transfer the power to the battery. That is regenerative power backup, regenerative generation, right? So this is regenerative braking mechanisms. Similarly, for the mechanisms. So for the reverse mechanisms, you have to turn on the switch 2 and then switch 3. So in that case, the motor will rotate in the reverse directions, and by changing the pulse width, we can vary the speed. So our ultimate speed is 0 to 20 kilometer per hour. 20 kilometer per hour, right? So in that case, we can if we change the motor speed from 0 to 100 rpm, then we can achieve this speed. So we can achieve this speed, right? So again, similarly from the reverse direction, so you have to remove the gate pulse from the switch 2, and then you have to enable the switch 4, and in that case the back EMF which is available on the motor will be dissipated. So when you are allowing to dissipate the back EMF within this loop itself, then the motor will comes to the zero speed at a very quick manner. So this is the regenerative braking. But in real time, so you have to implement regenerative braking at the same time the mechanical disc brake also required. So that is for safety standards. So for conceptual wise, this motor is this braking mechanism is enough. This braking mechanism is enough. Any more doubt? Any more doubt? To take it, right? So the amps rating only we are going to keep like a 60 amps, 60 ampere or 30 ampere based on your distance coverage. You can use it, and this is the main power supply. Similarly, for the additional two more power supply also we have to generate. One is called the gate driver power supply and Arduino power supply. So the gate driver power supply, as per our previous class discussion, for MOSFETs or IGBT, like a 15 voltage power supply is required for ground separations, because the motor is a high power motor, controller is a low power controller. So in that case, we have to isolate electronically. We have to provide the isolations between the microcontroller to the power circuit, right? Is what is no, sir? What is no? Can you just ask your questions? Can you just ask your questions? Braking mechanism for all wheel is required. Braking mechanism is required for all the wheel. For beam measurement and BMDC is a separate topic. So just ask your questions related to this concept, so that right system. Is there any scope in EV car maintenance business? Maintenance business definitely it will be there, but the entire EV market is changed as a investment basis. If you invest 5 lakh rupees, if you generate, if you install one EV station, charging station, then you can generate a nice business. Yes. Any more questions? Any more questions? Okay, thank you. So this is our desired vehicle. See here, this is the back seat and this is the front seat, and so this is the steering wheel mechanisms. So here we are going to keep two motors. So here one motor and then here the another motor. So my vehicle is ready. So tomorrow I will. This EV is suddenly stopped. What about then? Suddenly stopped. What about the time? Okay, what about the time? So actually that for prototype then there is no any standards requirement. If you are going for the commercials, there are lot of standards are there. We have to meet our designs should all the standards, all the standards. So tell something about charging stations. The charging stations, see here there are different type of charging stations are there. One is called a basic charging station. It is for the commercial charging stations, and similarly for the fast charging stations. See here, if you take any charging station, you have to invest like 2 lakh to 5 lakh rupees. So in that case, you will get a two charging station. One is 80%. So now the vehicle user will pay you. So automatically the EV charging machine will collect the amount from any online payment mode, and that amount will be calculated based on how much amount of current they took from the station. Right, so like mobile recharging business, how it is works. If you have any clear idea about that mobile recharging business, a similar kind of business is available on the EV charging stations. So initially you have to invest, then no, there is no any maintenance. Again, the company people will maintain their, they will provide lifetime warranty, because they are also going to make money from the business model. Right? So that kind of business only is going to happening in, as of now. But whenever the big companies entering into the market like Reliance, Tata, or any European countries, in that case the entire business scenario may change. But as of now in India, very few manufacturers are only there, like Relax and then Electro Power, and again big company corporates are just simply purchasing the charging station, that is the power converter from China or Taiwan. So simply they are just investing the money and then they are trying to penetrate the business. But as per the manufacturing process, like in India, very few people are there. Very few people are there, particularly the EV charging stations. How many company provides job in EV field? Makesh Kumar, I think you have not you have not have you don't have much idea about that things, right? See here, first you should prepare the your proper resume, and keep all the projects whatever you practiced here. You should just keep all the projects in your resume, and just to visit the Naukri. There are plenty of EV solution providers are here. So that is the biggest advantage in this EV market. Yes. So now tomorrow I will show you how the hardware demonstration. So if you have any more questions, you please ask me, and then you can ask your questions in the comment box. I will try to give you the answers. And the driver schematics and all I will give you tomorrow. So already I have given the various platform, like gate driver I have given the schematics. The same circuit only I am going to give you in the tomorrow class. See, after this course, you just go to Google, visit the Naukri page. openings for electric EV engineer. Right, just open here. So there are latest current jobs will be there, so you can apply here. So just check with your resumes also. That is based on your expectation, like a salary and experience. Then you can use it. Any specialized material for EV structures? Not like that. Whatever the IC engine structures are there, so the same thing only. IoT class is free or payable. YouTube always free, and then internship always chargeable. What is the special requirements of transformers? Transformers here doesn't require. Yeah, Dr. Govindraj, Tata Nexon is the one biggest milestone in the EV segment. Why can't we use electric vehicles for long distances? Who told the EV is not compatible for the long distance? Actually, the Tesla released that vehicle about for 350 kilometer on single charge. So 350 kilometer is not a small distance; it's a long distance only. Thank you, participants. Thanks for your valuable time here. And if you have any interest on this internship, you just use this coupon code batch5EV. So tomorrow is going to close that one. After that, the price will get revised. So if you feel this class give you the complete idea about that yeah, hardware basic selections, so please share your video feedback to my WhatsApp number, and also you can post your questions to my WhatsApp number. Thank you. Thank you. We will see you in the next class. Thank you once again.